In the next video lecture, I will concentrate on formation of oxide through the reaction of oxygen. Alkali metals as in previous lecture we have discussed on lithium, sodium, potassium, rubidium, cesium and francium. So these are the alkali metals. Francium is radioactive. Which has short lifetime. So it is not in our concentration. And lithium is the smallest alkali metal, right? As you know that atomic radius increases from top to bottom due to increase of extra outermost shell. So, and the density of these three alkali metal ion, lithium, sodium, potassium, density is less than water, right? And rubidium, cesium, francium, density is greater than water, right? These metals react on the surface of water vigorously, while these rubidium, cesium and francium metals remain in the sink of the water, and it reacts with water and explorates vigorously because of ignition of hydrogen in the water, and this hydrogen ignites and explodes. So these elements are highly reactive compared to lithium, sodium and potassium. Once lithium or sodium it dissolve is react with H2O, it forms alkali NaOH plus hydrogen gas is liberated in the reaction. So this is alkali, right? Similarly, lithium, sodium and potassium, they react with oxygen in the presence of air, then it forms lithium monoxide, which contains oxide anion. This oxide anion is diamagnetic, right? But sodium react with oxygen to form sodium peroxide, and this peroxide contains O2 2 minus, so this is diamagnetic. This is diamagnetic. And similarly, potassium K2O2, contains O2 2 minus anion, and this is also diamagnetic, right? But potassium onwards, like potassium, rubidium, and cesium, these metals react with oxygen to form superoxides, and the formula of superoxides K2 formula of select potassium, rubidium, cesium once react with oxygen, it forms KO2, similarly RbO2, similarly CsO2, right? It contains O2 minus. So this is a superoxide. Superoxide ion. Now this superoxide ion is paramagnetic. Right? So this is peroxide. This is peroxide ion. And this is generally oxide ion. Oxide ion. So there is a broad classification of oxide like normal oxide, superoxide, and peroxide, right? One another kind of sesquioxide forms if it reacts with ozone in the atmosphere, like potassium. If potassium react with ozone in the atmosphere, it forms similar to sesquioxide KO3, potassium ozonide. What we call it as potassium ionized. Potassium ozonide, which contains O3 minus as a ozonide ion. This O3 minus is called ozonide ion. So this ozonide ion has one unpaired free electron. One unpaired free electron. Due to presence of unpaired free electron, this ozonide ion is paramagnetic in nature. Paramagnetic in nature, right? So exclusively we can say that all alkali metals have different phase in same oxygen reactivity. It forms normal oxide, it forms peroxides, it forms superoxides, oxides, it forms ozonides. So alkali metal has these type of oxide structure, and the magnetic property of these oxides are different, and it can be applied to a particular field of research and innovations depending on the interest of oxide materials, right?